Hi everyone, this is Aman Kumar. Welcomes all of you at Brilliant Academy. Today I start a new playlist of mathematics for class 10th, and in this playlist you get the chapter wise lecture of all the chapters that you have to study in your class 10th. And this is the first video of this playlist. And in this video we study our first chapter, that is real numbers. Okay, so now let's start this video. You all study about classification of real numbers in your class 9th. What is this classification? So this classification said that real number is divided into two types. First one is rational number and second one is irrational number. Rational number is what? A number which can be written in the form of p by q, where q is not equal to 0 and p and q belongs to any integers. And irrational number is what? A number that can't be written in the form of p by q. It's called irrational number. Okay. Then after rational number we get integers. An integer then classified into three types. First is positive integer, second is negative integer, third one is zero. Positive integer is what? 1, 2, 3, 4, 5, 6, 7, 8. Negative integer is -1, -2, -3, -4, -5, 6, 7, 8. And 0 is what? 0 is neither positive nor negative. Okay. Then after you also knows about what is natural number and what is whole number. Natural number is what? A set of simple counting numbers which starts from 1. Then 1, 2, 3, 4, 5. These are natural number. Whole number is what? A set of number which start from 0. Then we say this is whole number, that is 0, 1, 2, 3, 4, 5. These are whole numbers. Okay, these all you studied in your class 9, and in class 10th you have to study about prime number, composite number, how to find LCM and HCF of any two integers, and last thing is fundamental theory of arithmetics. Okay, now let's move to our first topic, that is HCF and LCM. But before learning how to find HCF and LCM, we first understand what is factor and what is multiples. So factor is what? Factor is the number which divides the given number. Which means suppose you have one number, that is 12, and you have to write a factor of 12, which means you have to write the number which divides 12. Then think which number divides 12. 12 is divisible by 2, also divisible by 3, okay, also divisible by 4, also divisible by 6, also divisible by 12, and also divisible by 1, which means 12 has 2, 3, 4, 6, 12 and 1 is a factor, which means this number divides 12. Factor is the number which divides the given number. Then 2, 3, 4, 6, 12, 1 divides 12, which means 2, 3, 4, 6, 12 and 1 is a factor of 12. We take one more example. Suppose we have 18 and we have to write the factors of 18. Factors means write the number which divides 18. Then 18 is divisible by 1, 18 is divisible by 2 also, 18 is divisible by 3 also, and 18 is divisible by 6 also, 9 also, and 18. Then 1, 2, 3, 6, 9 and 18. These numbers are the factor of 18. These numbers are the factor of 18. Understood? What is factor? Factor is the number which divides the given number. Okay. Now let's see what is multiple. Multiple is the number which comes in the table of the given number. Which means suppose you have one number 6 and you write what is the multiple of 6, which means you have to write the numbers which comes in the table of 6. Which number comes in table of 6? 6 comes, 12 comes, 18 also comes, 24 also comes, 30 and so on. Then multiple of 6 is 6, 12, 18, 24, 30 and so on. Suppose you have another number, that is 9, and write the multiple of 9, which means we have to write the number which comes in that table of 9. Then which number comes in table of 9? 9 comes, 18, 27, 36, 45, 54 and so on. Then multiple of 9 is 9, 18, 27, 36, 45, 54 and so on. Okay, I hope you understand what is factor and what is multiples. Now let's move to our next concept, that is prime factorization. What is prime factorization? It is the process of breaking down a composite number into a product of its prime. Break down composite number into a product of its prime, which means suppose you have a number 18. 18 is a composite number. Composite number is what? A number which has more than two factors. Number which has more than two factors. then we say this number is composite number. Okay, then 18 has more than two factors, so it is a composite number. And in prime factorization we break this composite number into its product of prime, which means we have to divide this 18 by only prime number. Prime number is what? Number which has only two factors, number which has only two factors is called prime number. The prime number is what? Prime number is 2, 3, 5, 11, 13. 2 is only two factors, 1 and 2. 3 is only divided by only two numbers, 1 and 3. That's why these are prime numbers. Now, we break 18 into its product of prime, which means we have to divide 18 by only prime number. Then, first is by 2. 18 is divisible by 2, that's why I use 2. If 18 is not divisible by 2, then we use 3. Again, 5. First, 18 is divisible by 2, then 2 9s are 18. Okay, now this 9 is not divisible by 2, then we check by 3, then this 9 is divisible by 3, so I use 3. Now this 3 again not divisible by 2, this is divisible by 3, then 1. Now what is prime factorization is, we have to write product of its prime. Prime is this, then I write 18 is equals to 2 into 3 into 3. This is prime factorization of 18. This is the product of its prime, 2 into 3 into 3. Let's take one more example. Suppose I have 24. Now first I check with 2, then by 2 24 is divisible, then 2 1 are 2, 2 2 are 4, then 12 is again divisible by 2, then I write 2, 6 are 12, then 6 is again divisible by 2 3 times, then I write 3. Now 3 is not divisible by 2, then we check for next number, that is 3, then 3 is divisible by 3, sorry 3 is divisible by 3 at 1 times. Okay, then I write 24 as 2 1 2 3 times 2, 2 into 2 multiplied with 2 into 3. This is the prime factorization of 24. Okay, I hope you understand this, what is prime factorization. Now let's come to our first topic, HCF and LCM. HCF is highest common factor. Full form of HCF is highest common factor. And what is HCF? So HCF is a largest number which divides both of the given number. Suppose you have two numbers A and B, then HCF is the largest number which divides both A and B. Okay, and LCM is what? LCM is the smallest number which is divisible by both of the given number. Suppose you have two numbers A and B, then LCM is the smallest number which is divisible by A and B. HCF is what? HCF is the largest number which divides A and B, and LCM is a smallest number which divisible by A and B. Understood? Now let us take one example. First number is 144, second number is 180, and third number is 192. We have to find the LCM of 144, 180 and 192, and we have also find HCF of these three numbers. Okay, so for LCM and HCF, first we do prime factorization of all these three. Prime factorization of 144, 180 and 192. Okay, now first 144. This is divisible by 2, then 2 7 are 14, 2 2 are 4. Again by 2, 36 times. Then again 36 divided by 2 in 2 1 2 and 80, 80 are 16. Then again by 2, 9 times. Then again by 3, 9 times. Then 3 3 are, sorry, 3 1 are 3. And this is the prime factorization of 144. Now 180. Now 180. Again 180 is divisible by 2, then 2 9 are 18 and 0. Again 90 is also divisible by 2 at 45 times, then this is divisible by 3 in 15 times, then again by 3 5 times, then 5 is divided by 5 1 times. Okay, now prime factorization of 192. Now it is divisible by 2, 2 9 are 18, 1 are 2, 2 6 are 12. Again by 2, 2 4 are 8, 1 are 6, 2 8 are 16. Again by 2, 2 2 are 4, 2 4 are 8. Then again by 2, 12 times. Then again by 2, 6. Again by 2, 3. Then 3, 1. Okay, now this is the prime factorization of 144, 180 and 192. Now we write this. Prime factorization of 144 is what? How many times 2 occurs? 1, 2, 3, 4. 4 times. Then I add 2 to the power 4 into 3. How many times? 1, 2 times. Then 2. Okay. Now 180. 180. 180. 2 is only 2 times. Then I write 2 to the power 2. 3 is 2 times. Then 3 to the power 2. And 1, 5 is 1 times. Okay. Now for 192. 192. How many times 2 will occur? 1, 2, 3, 4, 5, 6. 6 times 2. Then 2 to the power 6 into 3 is 1 time. Then 3 to the power 1. Now we find HCF and LCM. HCF and LCM. Now for HCF, first you write all the numbers. Here is 2, 3 and 5. We have 3 numbers, 2, 3 and 5. 5 is in only 180, not in 192 and 144. Then I write 5 to the power 0 and 5 to the power 0. Anything to the power 0 equals to 1. That's why I write 5 to the power 0. This will become 1s. Now, there is 2, 3 and 5. First you write all the numbers. 2, 3 and 5. Now, for HCF, you write the lowest power of all these 2, 3 and 5. Lowest power, which means the smallest power. Now look, this is 4, this is 2 and this is 6. The smallest power is smallest among them, 6, 2 and 4 is 2. Then this is the smallest power, 2 to the power 2, this is the smallest. Then I write here 2. Now for 3, smallest is 2, 2 and 1. The smallest is 1. And for 5, the smallest power is 0. Then I write 0. Then this will become 2 to the power 2 is 4. 3 to the power 1 is 3. And 5 to the power 0 is 1. Then this is 4 3s are 12. Then HCF is 12. Our HCF of 144, 180 and 192 is 12. Okay. Now let's find LCM. For LCM, again you write all the numbers 2 into 3 into 5. Now look the power. For LCM, I write largest power. For HCF, you write a smallest power. For LCM, you have to write largest power. Now look for 2. What is the largest power of 2? This is 4, this is 2 and 6. This is the largest power. 2 to the power 6. Then you write here 6. Okay. Now for 3, which is largest? This one is largest. 3 to the power 2 is largest. So you write 3 to the power 2. And now for 5. 5 largest power is 1. Largest power of 5 is 1. Therefore I write here 1. Now calculate this. 2 to the power 6 is equals to 64. Now 3 to the power 2 is 9 and 5 to the power 1 is 5. Now multiply this. Then you get 64 multiplied by 5. 5 4s are 20. Okay, 6 5 are 30 and 32. 320 into 9. Then multiply this. 9 2s are 18. 9 3s are 27 or 128. Then LCM is 2880. HCF is 12. LCM is 2880. Okay. Again, let's see what is the method. First, the number is given 144, 180 and 192. We have to find LCM and HCF. Then first step is do prime factorization. First step, do prime factorization of all the given number. Then I do prime factorization of 144, 180 and 192. Then my prime factorization is this one, 144 this, for 180 this is, and for 192 this one. Okay. Now for HCF, first you write all the numbers. I have 2, 3 and 5. Then I write 2, 3 and 5. Next step, I write a smallest power of all the number. A smallest power of all the number for HCF. Then a smallest power of 2 is in this. A smallest power is this one, 2. That's why I write 2. A smallest power of 3 is 1. That's why I write here 1. And smallest power of 5 is 0. That's why I write 0. Then after calculating, I get HCF 12. And for LCM, again you write all the numbers 2, 3 and 5. And the power is largest. For HCF, power is smallest. For LCM, power you have to write largest power. Then largest power of 2 is 6. 3 is 2. 5 is 1. Then after writing this, I calculate 2 to the power 6 times is 64, 3 to the power 2 is 9 and 5 is 5. Then after multiplying, I get 2880 is the LCM. Okay, I hope you understand. Let's practice some more questions. Now this is our first question. Find the LCM and HCF of the following. First is 12, 15 and 21. We have to find LCM and HCF of 12, 15 and 21. First step is do prime factorization of all these three. Then first prime factorization of 12 is 2, 6 are 12, 2, 3 are 6 and 3, 3 are 1. 3 1 are 3. Okay, now for 15, this is divided by 3. 3 5 are 15. Then again 5 1 are 5. Now for 21, 3 7 are 21. Then again 7 1 are 7. Okay, now I write for 12 is 1 2 times and 3 is 1 times. Okay, then for 15 is 3 into 5. 3 into 5 both are 1 times. And for 21, 3 into 7 both is 1 times. Okay, now LCM and HCF. For LCM, what we do? Highest power. For LCM, highest power, then LCM is equals to, first I add all the numbers. There is 2, 3, 5 and 7. 2, 3, 5 and 7. We have 2, we have 3, we have 5 and we have 7. Now for LCM, we take highest power of all these number. Highest power of 2 is 2. This is the highest power. Then 2. Highest power of 3 is 1. 1 1 1. Then 1 is highest. Then 1. Highest of 5 is 1. And highest of 7 is also 1. Okay, now 1. Then calculate this. 4 into 3 into 5 into 7. Then 4 5s are 20. 7 3s are 21. 21 2s are 42. Then LCM is 420. And now HCF. For HCF, what we do? HCF is, for HCF we do smallest power. First I write all these three: 2, 3, 5 and 7. Now we take a smallest power. For HCF we take a smallest power of all these. A smallest power of 2, a smallest is 0. The smallest is 0. For 3, smallest is 1 1 and 1 1. For 5, smallest is 0. Why 0? Look, this is 0. There is 5 to the power 0 and 2 to the power 0. Write it. Now for 5, smallest power. The smallest power is 0. 7 is also 0. Then HCF equals to the power 0 1 into 3 into 1 into 7. Sorry, 1. Then our HCF is equals to 3. HCF is 3 and LCM is 420. Now let's do for second. There is 70 and 120. Then first step, find prime factorization for 70. 2 is 35. Then this is divisible by no 2, no 3, no 5. 7 times, then 7 1. Okay. Now for 120. 2 say, then 2 6 are 12, 0. 2 30. Then 2 say 15 times. Then again 3 by 5 times. Then 5 say 1 times. Okay. Now for 70, 2 into 5 into 7. Now for 120, what is 1 2 3? 3 times 2. 3 is 1 time and 5 is 1 time. Okay. Now in this there is no 7. Then I write 7 to the power 0. And in this 5 is not there. Sorry, 5 is there. 2 is there. Okay. No, 3 is not there. Then I write 3 to the power 0. Okay. And now LCM. First LCM. For LCM we take highest power. So first I write 2, 3, 5 and 7. Now highest power of 2. Highest power of 2. There is 3. This is the highest power. Highest power of 3. This is 0. This is 1. Then highest is 1. For 5, highest is, here is also 1. Here is also 1. Then highest is 1. Now for 7, highest is 1. This is 0. This is 1. Then 1. Now calculate this. 2 to the power 3 is 8 into 3 to the power 1 is 1. Sorry, 3 into 5 into 7. This is 5. Now calculate this. 8 3s are 24. into 5 into 7. Okay, now this is 24 5 ja 24 5 ja 5 4 ja 20, 5 2 ja 10, 11 and 12, 5 4 ja 20, 5 2 ja 11, 12 into 7. Now 12 7 ja 84, then LCM is 840. Okay, now HCF. For HCF we take smallest one, smallest power, then HCF is 2 into 3 into 5 into 7. Now a smallest power of 2, a smallest power of 2, 1. Okay, a smallest power of 3, this is 0, this is 1, then smallest is 0. For 5, smallest is 1 and 1, then smallest is 1. For 7, smallest is 0, this is 0 and there is 1, then smallest is this one, 0, then 0. Now calculate this. 2 to the power 1 is what? 2. 3 to the power 0 is what? 1. 5 to the power 1 is what? 5. And 7 to the power 0 is what? 1. Now from here HCF is 2 1 2, 5 1 5, then 5 to the 10. Our HCF is 10. LCM is 840. Okay, I hope you understand. You do this third one, 96 and 404 in your homework. Understood? Okay. Now our next topic is relation between HCF and LCM. This relation tells that HCF multiplied with LCM is equal to product of integers. Suppose you have two integers a and b. Then by this relation, HCF of a and b multiply with LCM of a and b. Then this product is equal to a into b. Okay, that is HCF of a and b is multiplied with LCM of a and b is equal to product of a and b. Understood? Let's understand this with taking some examples. Okay, now this is the first example. What is question? Question is find LCM and HCF of the following pairs of integers and verify the relation between, what is the relation? HCF and LCM is equal to product of integers. Verify the relation, that is LCM into HCF is equal to product of the integer. This is the relation and we have to verify this. So first we find LCM and HCF of 26 and 91. For LCM and HCF, first we do prime factorization. Then prime factorization of 26 by 2 times. 2 1 2, 2 3 6. Then again 13, 1. For 91, 7. 1 is 7, 21. 7 3 is 21. Then again by 13, 1. Okay. Now this is the prime factorization of 26 and 91. Now for 26, I write 2 into 13. And for 91, I write 7 into 13. 7 into 13. Power 1, power 1, power 1 and power 1. There is 2 is missing. So I write 2 to the power 0. And in this, 7 is missing. So I write 7 to the power 0. Okay. Now LCM. LCM is what? LCM is largest power. LCM is largest power. Then 2, 7 and 13. We have 2, 7 and 13. Now, LCM is largest power. Then largest power of 2. This is 0, this is 1. Then largest is 1. 7. Largest 1. Largest power of 13, 1. Then LCM is equals to 2 into 7 into 13. 27 ja 91. 2 into 91 is equals to 182. Okay, this is LCM. Now HCF. For HCF, we take a smallest power of all these three, 2, 7 and 13. A smallest power of 2 is 0. A smallest power of 7 is, this is 1, this is 0. Then this is 0. And 13 is 1. Then 2 to the power 0, 1. 7 to the power 0, 1. 13 to the power 1 is 13. Then HCF is 13 and LCM is 182. Now we have to verify this relation. For verification, first we consider LHS. First we go in LHS. LHS is LCM into HCF. LCM into HCF. So LCM into HCF. LCM is 182. 182. HCF is 13. Now multiply 182 and 13. There is 182 and 13. Okay. Now 3 to the 6. 8 3 are 24. Or 3 to 5. And this is 182. Then 6. 4 and 2 is 6. 8 or 5. 13 and 1 on 2. 2 3 6 6. LHS is 2, 3, 6 and 6. Now RHS. RHS is what? Product of integers, which means integer is 26 and 91. Then RHS is 26 into 91. Then multiply this 26 and 91. 26, 91. Then this is 26. Now 26 into 9. 9 is 54. Other 5. Or this is 23. Now 6. 4 into 6. This is 3. This is 2. 2, 3, 6, 6. Then RHS is also 2366. Now look, LHS is equals to RHS. LHS is equals to RHS. Then verified. Then this relation is true. LHS is equals to RHS. Then this relation is true. What is the relation? LCM of A and B into LCF of A and B is equals to product of integer, that is A and B. If there is two numbers, then the LCM of these two and HCF of these two is equals to the product of integers. Now this is our second example. Number is 510 and 92. Then we have to prove this relation for this number. Okay, again, okay. For LCM and HCF, first we take prime factorization. Then this one is divisible by 2. 2 to the 4, 1 and 1, 2 5 the 10, 2 5 the 10. Okay. Now this is divisible by 3. 3 6 the 3 8 the 24, 1 and 5. 3 5 the 15. Now this is divisible by 5. 5 1 the 5. Okay. 35, 5 7 35. Then again by 17. This is 1. Now 92. Again by 2. 2 4 the 8. 1 or 2. 2 6 the 12. Again by 2. 2 2 the 4. 2 3 the 6. Then 23. Then 1. Now write 5 1 10 is 5 1 10 is equals to 2 3 5 and 17. 2 into 3 into 17. Power is 1. Now 92. 2 2 and 3, which means 2 to the power 2 into 23. Okay. Now 5 is nothing and 17 is nothing, present in 92. So I add 5 to the power 0 and 17 to the power 0. And in this 23 is absent, then I add 23 to the power 0. Okay. 2, 23, 5, 17. This is 17, not 170. 2, 3, 3. 3 is nothing, then 3 to the power 0. Now LCM. 2, 3, 5, 17 and 23. 2 into 3 into 5 into 17 into 23. Now for LCM we take highest power of 2. This is 1, this is 2. Then 2 is highest. Now highest power of 3. For 3, highest power. This is 1 and in this 0. Then highest is 1. Then I write 1. Now for 5, which is highest? 1 is highest. This is 0, this is 1, then 1 is highest. Now for 17. For 17, this is 1, this is 0, then 1 is highest. Now for 23. This is 1. Then for 23, 1 is highest. Okay, now multiply this. This becomes 4 into 3 into 5 into 17 into 23. Okay. Now multiply this. 4 3 are 12. 12 5 are 60 into 17 into 23. Okay. Now 23 and 6. 23 and 6. 6 3 are 18. Okay. 6 2 are 12 or 13. 1380 into 17. Now 1380 into 17. Okay. 138 17. 7 8 ja 56 carry 5. Okay. 7 8 ja 56 carry 5. 7 3 ja 21. 21 or 5 26 carry 2. 7 or 2 9. 1 3 8 6 8 or 6 14. 9 or 3 12. 8 13 or 1 1 2 2 3 4 6. This is 2 3 4 and 6. Now HCF. LCM is 2 3 4 6. Now HCF. Again for HCF 2 into 3 into 5 into 17 into 23. Now for HCF we take a smallest power. Then a smallest power of 2. This is 1, this is 2. Then smallest is 1. Now a smallest for 3. 1 0. Then 0 is smallest. And for 5, which is smallest? There is 1 and there is 0. Then the smallest is 0. Now for 17, this is 1, this is 0. Then 0 is smallest. Now for 23, 1 0. 0 is smallest. Now from here HCF is 2 1 are 2, okay. 3 to the power 0, 1. 5 to the power 0, 1. 70 to the power 0, 1. This is also 1. Then HCF is equals to 2, okay. We have LCM 2, 3, 4, 6 and HCF 2. Now we have to verify this relation. So again, first we consider LHS, then our LHS is HCF into LCM, okay. Then HCF is 2, LCM is 2, 3, 4, 6. 2, 3, 4, 6. Now multiply this. 6 to the 12, 4 to the 8 or 8, 9. 3 to the 6, 2 to the 4. LHS is 4, 6, 9, 2. And now RHS. RHS means product of integers. Integer is 5, 10 and 92. Then 510 multiplied with 92. Now multiply this 510 and 92. 510 and 92. Okay. 0, 2 1 ja 2, 5 2 ja 10. Again 0, 9 1 ja 9, 9 5 ja 45. 0, 2, 9, 6, 4. Oh, I do one mistake. I left this 0. Then our LCM is 2, 3, 4, 6, 0. Then this will become 4, 6, 9, 2, 0. Okay. Now 510 multiplied with 92 become 4, 6, 9, 2, 0. Is equals to 4, 6, 9, 2, 0. Now look, RHS is equals to LHS. Then our relation is true. LHS is equals to RHS. Then our relation is verified, which means our relation is true. Understand? Now we have the next question. Question is what? The HCF of two numbers is 145 and their LCM is 2175. And if one of the number is 725, then find the other. Question is given. We have one number 725 and one another number which we have to find, and the LCM of these two is 2175 and HCF is 145. Then we have to find the other number. Okay. So for this, first we let this other number be x. Then let the other number be x. Okay. Second number is 725. HCF is 145 and LCM is 2175. Okay. Now we know the relation. What is the relation between LCM and HCF? That is HCF multiplied with LCM is equals to product of integers. Product of integers. This integers is x and 725. We have HCF, we have LCM. We have one number 725 and second number is x. Then we have find the x. HCF is 145. Okay. LCM 2175 and first number is 725. 725. Second is x. Now from this equation we find x. Then from there x is 145 into 2175 upon 725. Now cancel this. 5 and this one 5 times. 5 to the 10, 4 or 5, 5 1 is 45. Now 5 times this, 5 1 is 5, 2 or 2, 5 4 is 20, 25, 5 5 is 25. Okay, this one is 145. Now cancel this 5 and this by 5 times. 29 5, 29 5 is 145, 9 5 is 45, 4. 29 5 is 145, 29 5 is 145. Look here, 29 into 5. 9 5 is 45. Carry 4. 5 10, 11, 12, 13, 14. 29 5 is 145. Okay. Now from 5, this one is cancelled. 5 4 is 20. 1 or 7. Now 5 3 is 15. 2 or 5. 5 5 is 25. Then we have x is equals to 435. This is our answer. X is 435. Okay. Let's see again. What is the question? Question is what? There is a HCF of two number is 145 and LCM of two number is 2175 and one of them number is 725. Then we have to find the other number. Then what I do? First I assume first number be x. Then second number 725, HCF is given, LCM is given. Then by the relation. What is relation? HCF and LCM? is equals to product of integers. Then HCF 145, LCM 2175 is equals to 725 into x. Then from here x is equals to 145 into 2175 upon 725. Then by calculating this, I get x is equals to 435. Okay. Now let's move to next question. Question is what? The HCF of two number is 16 and their product is 3072. Then find the LCM. Question said that there is a two numbers. Okay, and the product of these two numbers is 3072 and the HCF of these two numbers is 16. Then we have to find the LCM of these two numbers. So we know the relation. What is the relation? LCM multiplied with HCF is equals to product of the number. Okay, now LCM, we have to find LCM. Then LCM into HCF. HCF is 16 and product is given 3072. Okay, now from this LCM is equals to 3072 upon 16. Okay, now cancel this one by 8. 8 to the 16, 3 the 24. Then we have 67. Okay, 67. 8 8 the 64. Then we have 32. Then 8 4 the 32. Now this 384 is cancelled by 2. 2 1 the 2. 1 8. 2 9 the 18. 2 the 4. Then our LCM is 192. Understand? Let's see one more time. Question is given that HCF of two numbers is 16 and the product of these two numbers is 3072. Then we have to find the LCM. Okay, question is saying that there is a two number and HCF of these two numbers is 16 and the product of these two numbers is 3072. Then we have to find the LCM of these two numbers. Then we know the relation between HCF and LCM. What is the relation? Relation is LCM multiplied with HCF is equal to product of the number. Now, then LCM, we have to find the right LCM into HCF is 16, I write 16 and product of the number is 3072. So I write 3072. Now, from this equation, LCM is equal to 3072 upon 16. Now, after calculating this, I get LCM is equal to 192. Okay. Now, let's move to our next question. Question is what? Can two numbers have 16 as their HCF and 380 as their LCM? Question is saying that we have two numbers. Okay. And we don't know what is the number. Question is asking for can these two numbers have 16 as their LCF and 380 as their LCM? This can be possible or not? This can be possible or not? So before solving this question, first we understand there is a one concept. Concept is what? HCF is a factor of LCM, which means HCF completely divides LCM for all numbers. For all numbers. For all numbers. Factor is what? Factor is a number which divides a given number. Now look this. HCF is a factor of LCM, which means HCF divides LCM completely. HCF divides LCM completely. Now in this case, question is asking for can two numbers have 16 as their HCF and 380 as their LCM? Now question is asking HCF is 16 and LCM is 380. Okay, now if this HCF 16 divides LCM 380 completely, then I write yes, this is can be possible, otherwise not possible. So first let's check 16 divides 380 or not. Now 16 to the 32, 0. Now this is 6. Now this is okay. Now 16 to the 32, 16 3 is 48, 16 4 is 64. Now 16 3 is 48. Then this will become 2 and this 5 12. Okay, now 16 can't divide with 3. Therefore, now 16 cannot divide 380. Therefore, this cannot be happen. Therefore, this cannot be possible. What is not possible? That two numbers don't have 16 as their HCF and 380 as their LCM. This cannot be possible. Understand? Let's see this question again. Question is asking that there is a two number and one possibility is, what is the possibility? Can 16 as their HCF and 380 as their LCM. There are two numbers and question asking for can this is possible or not that these two numbers have 16 as their HCF and 380 as their LCM. Okay, so there is one concept. What is this concept? HCF is a factor of LCM, which means HCF completely divides LCM. If this is possible, then I write yes, this can be possible. These two numbers have 16 as their HCF and 380 as their LCM. If 16 does not divide 380 completely, then this cannot be possible. Now let's check it. HCF 16, LCM 380. So I divide it 16, 380. Then I see here 16 cannot divide 380 completely. That's why I write this cannot be possible. Understood? Now let's move to our next topic, that is prime number and composite number. What is prime number? A number which have only two factors. A number which only have two factors, then we say this number is prime number. And which of them are two factors? First one is 1, first factor is 1 and second is the number itself. Example 2, 3, 5, 7, 11, 13 and 17. Write the factor of 2. Factor of 2 means 2 is divisible by which number? First 1 and 2. Now rather than 1 and 2, there is no number which divides 2. Now look factors, 1 factor, 2 factor, and first is 1. First factor is 1 and second is the number itself. Second is the number itself. Then 2 is prime number. 3 is also 3. Factor of 3 is 1 and 3. First factor is 1. Second factor is number itself 3. Then I write 3 is a prime number. Look 13. 13 is divisible by 1 and 13. Now 13 is divisible by 1 and 13 and first factor is 1 and second factor is 13 itself. That's why 13 is also a prime number. 17 is also a prime number. Now what is composite number? Number which have more than two factors. Number which have more than two factors. Then we say this number is composite number. That's example 9, 12, 15, 18. What is the factor of 9? If you write what is the factor of 9, then 9 is divisible by 1, 3, 9. More than two factors, there is 1, 2, 3. Total 3 factors. Then 9 is composite number. In case of 18, what is the factor? 1, 2, 3, 6, 9 and 18 itself. 1, 2, 3, 4, 5, 6. There are total 6 factors of 18, which is more than 2. That's why 18 is a composite number. 9 is a composite number. Understand? What is prime and what is composite? The number which have only two factors is called prime number. The number which have more than two factors is called composite number. Okay? Now there is one more thing. What is this? This is 1 is neither prime nor composite, which means 1 is neither prime nor composite. Let's see the case of 1. We have 1, write the factor of 1. 1 is divisible by only 1 itself. Now, what is prime number? Prime number which has two factors. Number which has two factors is called prime, and composite which has more than two factors. More than two factors. This number is called composite number. Now look, in case of 1, factor of 1 is only 1. Okay. Now this is less than 2. This is not only 2 factors, and this is also less than more than 2. That's why 1 is neither prime nor composite. Okay. 1 is neither prime nor composite. Now let's practice some questions regarding prime and composite number. Our first question is what? Explain why 3 into 5 into 7 plus 7 is a composite number. This is a number. We have to explain why this number is a composite number. Understood? So first I write the given number. Given number is 3 into 5 into 7 plus 7. Okay. Now look, from this and this, we take 7 as a common. Then we have left 3 into 5, and from here we left 1. Okay. Now this one look like 7 multiplied with 3 into 5, 15 plus 1. Then again 7 into 16. Okay. And 16 into 7 is equal to 112. Okay. This will become 112. Now see, this 112 has 7 and 16 both is a factor. 7 into 6 is 112. Then clearly you see that 112 has 7 and 16 is a factor. 7 and 16 is a factor. Then this is a composite number. Why? Prime number is what? Only two factors. Then we say prime number. And here look, 16 and 7. 16 and 7 is a factor, and 112 is also 1 and 112 is factor. Then total number of factor is 1, 2, 3, 4. Then we say 112 is a prime number. Sorry, is a composite number, not a prime number. So here I write clearly. We see that 112 have 7 and 16 as a factor. Therefore, 112 is a composite number. Okay, understood? Let's see again. Question is what? There is a number which is this. Prove that this is a composite number. Okay. So first I write this number, then I take 7 as a common. Then what we left in this, we left 3 into 5, and from here we left 1. Now 7 into 3 5 is 15 plus 1. Then 7 into 16 is equals to 112. And now look, 7 into 16 is 112, which means 7 and 16 is a factor of 112. So I write clearly, we see that 112 has 7 and 16 as a factor well. 112 has 7 and 16 is a factor. Therefore, this is a composite number. Understood? Now let we see one more question. Question is explain why this number 7 into 11 into 13 plus 13 is a composite number. Again we do same step. First I write this number. Number is 7 into 11 into 13 plus 13. Now second step I take common from this 13 and from this 13. Then we take 13 as common. Then what we left? 7 into 11 plus 13. Okay. Then 13, 11 7 ja 77 plus there we left 1 plus 1. Okay. Now 13 into 78. If you multiply this will become 1014. 1014. Okay. Now look, this 1014 has 13 and 78 is a factor. 13 and 78 is a factor. So I write clearly, we see that 1014 have 13 and 78. 13 and 78 as a factor. Factor well. Therefore, 1014 is a composite number. Let's see it again. Question is explain why this number is a composite number. I write this number, then from this number I see there is 13 as common. Then I take 13 as a common. Then we have 13 left, 7 into 11 and 1. After calculating this, we get 1014, and we see 1014 has a factor 13 and 78. That's why I write clearly, we see that 1014 have 13 and 78 as a factor well. Therefore, 1014 is a composite number. Okay, understood this? Now let's move towards our next topic, that is word problem of HCF and LCM. Okay, so for solving this word problem, we have to follow these steps. First step is what? Read the question carefully. Okay. Second step is now judge your answer will be greater or smaller than the given data. And third step, if your answer is greater, then you have to find LCM. Okay. And if your answer is smaller, then you have to find HCF. Okay. Let's read it again. First step, read the question carefully. First step, read the question carefully. Now second step, judge your answer which is greater or smaller than the given data. Third step, if your answer is greater, then you have to find LCM, and if your answer is smaller, then you have to find HCF. Understood? Let's take some example. Suppose your given data is 2, 8 and 7. Okay. Now you judge that your answer, suppose your answer is 9. Now look, your given data is 2, 8 and 7, and you judge that your answer is 9. Then see, 9 is greater than 2, 8 and 7. Then 9 is greater. If your answer is greater, then you have to find LCM. Then for solving this word problem, you have to find LCM of 2, 8 and 7. LCM of given data. And suppose your answer is 6. Sorry, suppose your answer is 1. Okay. Now look, answer is 1 and 1 is a smaller. Then you have to find HCF. A smaller, then you have to find HCF of 2, 8 and 7. Understood? In case of greater, you have to find LCM. If your data is smaller than the given data, then you have to find HCF. Okay, let's take some example, then this concept will clear very well. Now, this is our first question of word problem. Question is what? Three bells are rings at an interval of 6, 12 and 18 minutes respectively. Okay. If all three bells ring at 6 am, then when will they ring together? Okay. Now look, question is what? Question is saying that there are three bells which rings at an interval of 6, 12 and 18 minutes respectively. And these three bells rings at 6 am morning. Then question is asking for at which time again these three bells ring together. Understood? So first we write given data. First we write given data, then we analyze our answer is greater or smaller than the given data. First our given data is 6, 12 and 18. Now look, first bell for first bell. Suppose first bell rings at 6 am. Second bell also ring at 6 am and third bell also rings at 6 am. Now next time, for next time this bell rings after, first bell rings after 6 minutes, interval of 6 minutes, then this bell rings after 6 minutes. Okay, now this bell rings after 12 minutes and this bell rings after 18 minutes. Okay, then this bell rings at 6:06 am, this is 6:12 am and this one is 6:18 am. Okay, now look, our answer is greater than the given data. Our answer is greater than this given data. Given data is 6, 12 and 18 minutes. Our answer is greater than this given data. If our answer is 5 minutes, after 5 minutes these three bells rings together, then this can't be possible. Why? Look, first bell rings after 6, second after 12. 5 is smaller, then this can't happen. Now suppose all these three bells rings after 13 minutes, then this can't be possible. First at 6 am, then second time first bell rings at 6:06, second one rings at 6:12 am and third one 6:18 am, then again at 6:13 am. All these three bells can't ring together. Now let's suppose our answer is 18 minutes. Okay, now look, at 6:18, at 6:18 first bell rings second time at 6:06 am, second 6:12 am, third 6:18. At 6:18 third bell rings, but these two bells doesn't ring. That's why this cannot be possible, which means our answer is greater than 6, 12 and 18. Our answer is greater than 6, greater than 12 and greater than 18 also. Our answer is something, suppose our answer is x minute, then this x is greater than 6, 12 and 18. So now in case of greater, we have to find, in case of greater we have to find LCM. In case of greater we have to find LCM, then we have to find LCM of 6, 12 and 18. Understood? We have to find LCM of 6, 12 and 18. Now for LCM what we do? We do prime factorization. I simply do 6, 12 and 18. Okay, I do prime factorization at the same time for all these three. Now 2 3s are 6, 2 6 are 12, 2 9 are 18. Okay, now this is 3 1 are 3, 3 2s are 6, 3 3s are 9. Okay, now from here LCM is, from here LCM is equal to 2 into 3 into 1 into 2 into 3. Now multiply these. So LCM is equal to 2 3s are 6, 3 2s are 6. Then LCM is 36. Then after 36 minutes, these three bells rings together. After 36 minutes means, after 36 minutes, these three bells rings together. After 36 minutes, first time 6 am, then at 6:36, at 6:36 am they rings together. Understood? Again look, question is what? There is a three bell which rings at an interval of 6, 12 and 18 minutes. Okay, and at 6 am morning these three bells rings at the same time, then question asking for at what time again these three bells ring at the same time. Then I judge my answer is greater than the given data 6, 12 and 18. I judge my answer is greater than the given data 6, 12 and 18. Then in case of greater, we have to find LCM. In case of greater answer from the given data, we have to find LCM. That's why I find LCM of 6, 12 and 18. Then LCM of 6, 12 and 18, I got 36. Then after 36 minutes, these three bells rings together, which means first time 6 a.m. Then at 6:36 a.m. these three bells rings together. Okay. Now look our second question. Question is what? Question is saying that what is the smallest number that when divided by 35, 56 and 91 leaves remainder 7 in each case. Question is saying that find the smallest number which when divided by these three numbers 35, 56 and 91, then the smallest number leaves remainder 7 in each case. For this, first forward this line, leaves remainder in 7 case. First forget this line, you only focus on this. What is the smallest number that when divided by 35, 26 and 91 leaves remainder 0, not remainder 7. First focus on this. What is the smallest number which is completely divided by this one? Okay. So first write given data. Given data is 35, 56 and 91. Now look for our smallest number. Smallest number. Now second step, we have to judge this smallest number is greater or smaller than these three. Okay, greater or smaller than these three. Now suppose there is 2 and you have to write what is the number which is completely divided by 2. You have to write the number which is completely divided by 2. Then you write 4. 4 is completely divided by 2. 8. 8 is also completely divided by 2. 16. It is also completely divided by 2. 10. It is also completely divided by 2. Now look, all the numbers which is completely divided by 2 is greater than 2, is greater than 2, is greater than 2. So in case of this, all the numbers which is completely divided by 35 is greater than 35. All the numbers which is completely divided by 56 is also greater than 56. And all the numbers which is completely divided by 91 is also greater than 91, which means our answer is greater than given data. Our answer is greater than given data. And in case of greater than given data, we have to find LCM. We have to find LCM. So our answer is greater than given data. Then we have to find LCM of what? 35, 56 and 91. So 35, 56 and 91. This is 35, 56 and 91. Okay. Now this is cancelled by 3. This is 35 now, 3 and 56. No, this is not cancelled by 3. First we cancel by 7. 7 5 is 35. 7 is 56 and 91. 37 is 91. Okay. Now these three cannot be cancelled. So our LCM is 7 into 5 into 8 into 13. Now multiply this. 7 8 ja, 7 8 ja, 56, 13 5 ja, 65. Now multiply this. 56 and 65. So now 6 5 ja, 30, carry 3, 5 5 ja 25 or 3 28, 6 is 36, carry 3, 6 5 ja 30, 33, then 0, 8 or 6, 14, 3 to 5 or 6, 3. Then LCM is 3640. Now 3640. So 3640 is the smallest number which is completely divided by these three, 35, 56 and 91. Understood? 3640 is the smallest number which is completely divided by these three. But we have to find a smallest number which is divided and leaves remainder 7 in each case. We don't find completely divided. We have to find the number which leaves remainder 7 in each case. Now look for, if you have 2 and you have 15. Okay. Then and you divide 15 by 2. Then what is the remainder? What is remainder? This one is 14. Remainder is 1. Okay. Remainder is 1. Now if you have to find out, there is 14 and this is 2, and find the smallest number which is divided by 2, leaves remainder 1. Then what is small? Then you simply add 14 plus 1, that is 15. 15 is the smallest number which is divided by 2, leaves remainder 1 in each case. Similarly, in this case, I use this one. I add 7 in this. I add 7 in 3640, then I get the smallest number which is completely divided, sorry, which is divided by these three leaves remainder 7 in each case. Understood? So, for smallest number, I add 7 in this 3640. 3640 plus 7. Then this will become 3647. Okay. Now this is our answer. A smallest number which is divided by 35, 56, 91 leaves remainder 7 in each case. Okay. Understood this? Let's see again. Question is asking for find a smallest number which is divided by these three 35, 56, 91 leaves remainder 7 in each case. So first I find a smallest number which is completely divisible by these three. Then for this I have to find LCM. Then LCM is 3640. Then this is the smallest number which is completely divisible by these three. But we have to find a number which divided by these three leaves remainder 7 in each case. So I add 7 in the LCM. Then I get 3640. Okay. And now 3647 when divided by 35, 56 and 91 leaves remainder 7 in each case. Okay. If you have doubt, then you divide, then you get your proof. Okay, I divide by 35, 5 only. In your home, you divide by 56 and 91 and check that this answer is true or not. Now 35, 35 1 ja, 35, 4, 6, 5, okay, 14. Now 0, then 0, 1, 4, 7. Okay, now 35 or 147. 3 4s are 3 4s are 12. Now 35 into 4, 5 4s are 20, 2 are 13, 14. 4 the 140. Then this will become 7. Look, remainder is 7. Leaves remainder 7. Okay. And if you check by dividing 56 and 91, then you also get remainder 7. Understood? Now let's move to our next question. The question is what? A rectangular courtyard is 18 meter 72 centimeter long and 13 meter 20 centimeter broad. It is to be paved with square tiles of the same size. Then find the least possible number of such tiles. Okay. The question is what? There is a rectangular courtyard. Okay. And this courtyard is paved with a square size tiles. And the length of courtyard is given 18 meter 72 centimeter long and 30 meter 20 centimeter broad. And we have to find the possible number of such tiles. Okay. For this number of tiles, first we have to find area of tiles, and for area of tiles we have to find side of a square, and for side of square we have to take HCF. HCF of what? HCF of length and breadth. Why we take HCF? Look, this is your rectangular courtyard. Okay, now this is paved by a square tiles, something like that. Okay, this is your square tiles. Okay, now look, this length and this breadth of rectangle, breadth and length, and suppose this is your tile, square tiles, then this is size of square, this is size of a square. Okay, and now look, this side is always smaller than length of rectangle and length of, I'm sorry, breadth of rectangle. This side of a square is always smaller than length and breadth of rectangle. And if in case of smaller answer, we have to take HCF. In case of larger, we have to take LCM. And in case of smaller answer, then we have to take HCF of given data. Understood? So we have to take HCF of length and breadth. So first I write length. Length is what? 18 meter 72 centimeter. Okay. So first change into centimeter. For changing centimeter, 18 into 100 plus 72, this, and this will, okay, now this is 1872, 1872. Now breadth, it is equals to 13 meter 20 centimeter. Now 13 into 100 plus 20, so this will become 1300 plus 20, 1320. 20 centimeter. This is centimeter. 1872 centimeter. I write direct here. 1872 centimeter. 1872 centimeter. Okay, and I erase this one. And similarly, in case of breadth, I write 1320 centimeter. 1320 centimeter. Now we have to take HCF of 18720 and 1320 centimeter. 4. Now HCF of this one. HCF of 1872 and 1320 equals to, first we have to do prime factorization of 18720, 18,070 meter, 18,072 centimeter, and prime factorization of 1320 centimeter. Now 1872, 2 9 18, 2 3 6, 2 6 12, 2 4 8, 2 6 12, 2 8 16, 2 2 4, 2 3 6, 2 4 8, 2 1 2, 2 1 2, 2 7 14, 3 6 is 9, 10 11 27, 3 9 27. Again 3, 3 1 3, 3 3 9. Again by 13 1. So 1872, 1872 I write 1872 as 1 2 3 4, 4 times 2 and 2 times 3 and 1 times 13. Similarly 1320, 1320. Again by 2, 2 6 are 12, 1 and 2, 2 6 are 12 and 0. Okay. Now again by 2, 2 3 are 6, 2 3 are 6, 0. Again by 2, 2 1 are 2, 1 are 3, 2 6 are 12, 1 are 0, 2 5 are 10. Again by 3, 3 5 are 15, 3 5 are 15, 1 by 5, 11. Then 172 and 1320 is equals to 1 2 3. 3 times 2, that is 2 to the power 3, 1 times 3 and 1 time 5 and 1 time 11. This is 11. Okay. This is prime factorization of 1320 and 1872. Now we find HCF. For HCF, what I write? For HCF, we take a smaller power of all these three. Now look, in this 11 is not present, so I write 11 to the power 0. 5 is also not present, I write 5 to the power 0. In this case, 2, 3, 5, 11. 13 is not present, so I write 13 to the power 0. Now write all these three. 2, 3 into 5 into 11 into 13. Now for HCF, we write smallest power, then smallest power of 2 is 3. A smallest power of 3, here is 1 and 2, this is 1. A smallest power of 5, 0. A smallest power of 11, 0. And 13 is 0. So HCF is equals to 2 to the power 3 is 8. 3 to the power 1 is 3. Then HCF is 24. We have HCF is 24, and now this HCF is equals to the side of a square tiles. So side of a square tiles. This HCF is equals to side of tiles is equals to HCF. HCF is 24, then is 24 centimeter. Now we have side of tiles, so we find the area of tiles and area of this rectangular courtyard is equals to area of square tiles. Area of rectangle, if this is your rectangular courtyard and you put it square tiles, then the area of all square tiles, 1 2 3 4 5 6 7 8, all 8 square tiles is equals to area of courtyard. Okay, understood? Area of courtyard. So from this I write area of tiles is equals to area of courtyard. Area of tiles is equals to area of courtyard. Now area of tiles is in shape of a square. The area of a square is side square. I write a square. Okay, area. Now area of courtyard. Courtyard is in shape of rectangle. Then area of rectangle is L into B, A square, side square, 24 into 24, 24 into 24. And how many? We let assume x. We have x number of tiles. Area of one tile is 24 and total tiles we required is x. So this is 24 into 24 is equal to x. Now L into B. L is 1872 centimeter. 1872 centimeter into breadth. Breadth is 1320 centimeter. 1320 centimeter. Now from here x is equal to what? X is equal to 1872 into 1320 upon 24 into 24. Now calculate this. This is cancelled by 8. 8 3s are 24 and this is also by 8. 8 1 is 8, 8 was 16, 8 2 is 16, 17 into 27, 8 2 is 16, 8 3 is 24, 25, 26, 27, 32, 8 4 is 32, 234. Now 4 2 6 3 9, this is cancelled by 3. 3 7 is 21, 22, 23, 24, 3 is 24, okay, 78. Now 24 and 78. Again by 2. 12 2 is 24 and this 78 by 2. 2 3 is 6 and 1 8. 2 3 is 6, 1 8. 2 9 is 18, 39 and 12. 39 and 12. Okay. Now this one. 3 3 to 5 6. This is cancelled by 3. 4 3 is 12 and this is by 3. 3 3 is 9, 3 4 is 12. 1 2, 3 4 is 12. 0. Again 4 say 440. 4 1 is 4, 4 1 is 4 and 0. Then we have x is equals to 39 into 110. Now multiply 39 and 11. 39 and 11. This is 39, 39, 9, now to 12, 12, 4, 424. Then x is equals to 424 tiles. Then we have 4440 tiles required to pave this rectangular courtyard, which has length 18 meter and 72 centimeter and breadth is 30 meter and 20 centimeter. Understood? Now let us see one more time. Question is what? Question is there is a rectangular courtyard of length this and this, and this courtyard is to be paved by a square tiles. Then we have to find the least possible number of such tiles. We have to find how many tiles required to pave this rectangular courtyard. Okay. Now for this number of tiles, we first have to find area of a square tiles, and for area of a square tiles we have to find side of a square. Okay, and for side of a square we have to find HCF of rectangular courtyard length and breadth. HCF of length and breadth of this courtyard. Why HCF? Because side of a square is always smaller than length and breadth of a rectangular courtyard. That's why I find HCF. In case of a smaller answer, we have to find HCF of given data. So length is this one, 1872 centimeter, and breadth 1320 centimeter. Then HCF of this both is 24. Now this HCF is equals to side of tiles, and side of tiles is equals to this HCF. So again, area of tiles is equal to area of courtyard. Why? Because this is your rectangular courtyard. This is one square tiles, 2, 3, 4, 5, 6, 7, 8. Then in this case, area of all square tiles is equal to area of this rectangular courtyard. That's why I write here area of tiles is equal to area of courtyard. Okay. Then area of tiles is a square. Why? Side is a square. Then area of a square is a square, and area of courtyard is in shape of rectangle. That's why I write L into B. Now side square 24 into 24, and let us assume total number of tiles is x. That's why I write here x, and length into breadth is this one. After calculating this, I get x is equal to 4290 tiles. So we have required 4290 tiles to cover this rectangular courtyard. Understood? Now let's move toward our next topic, that is proving irrationality. In this topic, we have to prove a number is an irrational. So our first question is prove root 3 is an irrational number. We already know that root 3 is an irrational number. Why irrational number? Because root 3 is not a perfect square. That's why root 3 is an irrational number. Okay, now In this question, we have to prove that root 3 is an irrational number. Okay. So for proving this, we use a contradiction method. Okay. So for using this method, first we assume let root 3 is a rational number. Okay. Then if root 3 is a rational number, then I write root 3 is equals to p upon q, because rational number is in the form of p upon q, and p and q are co-prime. Co-prime means if the HCF of two numbers is 1, if HCF of two numbers, suppose a and b, equals to 1, then we say a and b are co-prime. Understood? Are co-prime. Okay. Now look, root 3 is equal to p and q, where p and q are co-prime. Now next step is squaring both sides. Squaring both sides. Then root 3 square equals to p upon q square. Now root 3 square is 3 equals to p square upon q square. Now from this q square goes that side, then this will become 3q square equals to p square. Understood? Now this is our equation first. Okay. Now from here I write, look, if you have 2 into 5 equals to 10, so by this you write now 2 divides 10. From this you write 2 divides 10. See, 3q square equals to p. Then you write 3 divides p square. Okay. And now if 3 divides p square, then 3 also divide p. Okay. Suppose if 2 divide 36, then 2 also divide 6. 6 square is 36. Okay. 6 square is 36. Then I write 6 square is 36. Then if 2 divides 36, which means 6 square, then 2 also divides 6. Similarly, if 3 divides p square, then 3 also divides p. Okay. Now this is our equation number 2. Understood? Now let p is equals to 3c. Okay. Now let p is equals to 3c. P is equals to 3c. Okay. Now put this p is equal to 3c in equation first. Now put p is equal to 3c in the equation first. Put p is equal to 3c in equation number first. Equation first is 3q square. 3q square is equals to p square. P square. Then p is equal to 3c. Then 3q square is equals to 3c whole square. Then this will become 3q square is equals to 9c square. Okay. Now from here q square is equals to 9c square upon 3. Then 3. Now q square is equals to 3c square. Okay. Now from here again I write 3 divides q square. From here again it's clear that 3 divides q square. Then यहाँ 3 divides q square, and when 3 divides q square, then 3 also divide q. This is our equation number 3. Okay. When 3 divides q square, then 3 also divide q. Okay. Now look, from equation second and third. From equation second and from equation third. We see clearly that 3 is a factor of p and q. P and q as well. Okay. From 2 and 3, if 3 divides p and 3 divides q, factor is what? A number which divides the given number. then if 3 divides p, then this is 3 is a factor of p, and if 3 divides q, then 3 is also a factor of q. So, and what we assume that p and q are co-prime. Co-prime is they have only one factor, that is 1. So therefore our assumption is wrong. That's why, therefore, root 3 is an irrational number. Irrational number. Understood? Let's see it again. Question is what? Prove root 3 is an irrational number. Okay. So first step, we assume that root 3 is a rational number. Okay. Then if root 3 is a rational number, then root 3 is equals to p upon q, where p and q are co-prime. Co-prime is p and q have only one HCF as 1, which means p and q have only one factor, that is 1. Now second step is squaring both sides. Squaring both sides. Then after squaring both sides, I get 3 is equals to p square upon q square. P square upon q square. Now from here 3q square is equals to p square. This q square goes that side. Then from here I write 3 divides p square, and when 3 divides p square, then 3 also divides p. Okay. And now let again next step, let p is equal to 3c, and after letting p is equal to 3c, we put p is equal to 3c in equation first. Equation first is 3q square is equal to p square. Now put 3c square in place of p, then we get 3q square is equal to 9c square. Then this 3 goes that side, then q square is equal to 9c square upon 3. Then q square is equal to 3c square. Now look, from here I add 3 divides q square, and when 3 divides q square, then 3 also divides q. And from 2 and 3, look, if 3 divide p, then 3 is a factor of p, and 3 also divides q, then 3 is also a factor of q. Then from 2 and 3, we see clearly that 3 is a factor of both p and q. Okay. Therefore our assumption is wrong. Which assumption? We assume that p and q have only factor 1, and rather than 1 it don't have any factor. But from equation 2 and 3, we see that 3 is also a factor of p and q. That's why our assumption is wrong. Therefore root 3 is an irrational number. Understood? Now let's move towards our next question. Question is what? Prove that 5 plus root 3 is an irrational number. Okay. In this question we have to prove 5 plus root 3 is an irrational number. Then again same step. First we let 5 plus root 3 is a rational. Okay. Then if 5 plus root 3 is rational, then I write 5 plus root 3 is equals to p upon q. Okay. 5 upon root 3 is equal to p upon q. Now from here you write 5q plus root 3 q equals to p. Okay. Now from this root 3q is equals to p minus 5q, and q is equals to root 3 is equals to root 3 is equals to p minus 5q upon root 3. Now look, root 3 is an irrational number. Root 3 is an irrational number. Okay, and this is a rational. P by q is a rational, where p and q are co-prime. This is rational. This one is rational, and this root 3 is irrational number. This can't be possible. Irrational is equal to rational. This can not be possible. This can't be possible. So therefore root 3 is an irrational. Therefore our assumption is wrong. Therefore 5 plus root 3 is an irrational number. Proved. Understand how this is proved? Let's see it again. We have question, prove 5 plus root 3 is an irrational number. So first step, we let root 5 plus root 3 is a rational. Then if it is rational, then I write 5 plus root 3 in the form of p by q. If this is rational, then I write this, and after solving this equation, we get root 3 is equals to p minus 5q upon root 3. Now look, root 3 is irrational, root 3 is irrational, and this one is rational. This can't be possible. Irrational is equal to rational. This cannot be possible. That's why our assumption is wrong, and 5 plus root 3 is an irrational number. Okay. If this question occurs in your exam, then this is given that root 3 is an irrational. Okay, this is given in your question. If suppose question is like that, 5 plus root 2, then this is given root 2 is an irrational. Okay, and if this is not given root 2 is an irrational, then you have to first prove root 2 is an irrational, then you prove 5 plus root 2 is an irrational number. Okay, understood? Now let's move towards our last topic, that is fundamental theorem of arithmetic. This theorem said what? That we write any composite number as a product of primes, and this product is unique for that number. Which means suppose I have a number 40, I write 40 as a product of prime, which is 2 into 2 into 2 into 5, and this is unique. This is 2 into 2 into 2 into 5, this is unique, and this is always available for 40, not for a different number. Suppose I have 60, then the product of prime for 60 is different, something different, but not like that, this is totally different, not like that. This is only available for 40. This product of prime is only available for 40, not for any other number. This is a fundamental theorem of arithmetic, that is we write any composite number as a product of primes, and this product is unique for that number, unique for that number. Understood? Now this is our question. Question is what? Check 6 to the power n can ends with 0 for any natural number n. Okay, this is n is an any natural number. Can 6 to the power n ends with 0 or not? We have to check this. So first 6 to the power n. First you write prime factorization of 6. This is 2, 3, 1. Prime factorization is 2 into 3 to the power n. Then 6 to the power n is written 2 to the power n into 3 to the power n. Okay, now look, if any number to be ends with 0, then this number have to be 2 or 5 in their prime factorization. Suppose this is 10, 10 ends with 0. If you do prime factorization of 10, then 2 into 5, then this will look like 2 into 5. Okay, now look, 2 and 5 is in the prime factorization of 10. Suppose 20, then do prime factorization of 20, 2, 10, 2, 5, 1. You look, 2 into 2 into 5. Again, 20 also has 2 into 5 in their prime factorization. Suppose you write 50. Again do 50. Then this is 2, 25, 5, 5. Again 50 also has 2 into 5 into 5. 2 into 5 in their prime factorization. Which means if a number which ends with 0, then this number have 2 and 5 in their prime factorization. And look, 6 don't have 2 and 5 both. 6 only have 2, not 5. Then therefore 6 cannot have 2 and 5 in their prime factorization. So 6 to the power n cannot ends with 0. Okay, understood? Let's see it again. Question is what? Check 6 to the power n can ends with 0 for any natural number n. So for ends with 0, a number has to be 2 and 5 both in their prime factorization. Look, 10 have 2 and 5, 20 also have 2 and 5, 50 also have 2 and 5 in their prime factorization, and 6 have 2 and 3, only 2, not 2 and 5. Therefore 6 cannot have 2 and 5 in their prime factorization. That's why 6 to the power n cannot end with 0. Understood? Thank you so much for watching this lecture. If this lecture is useful for you, then like, share and subscribe to the channel. Okay.